Okay, so let's see more detailed things about what I am doing. One thing I'm doing right now is optical imaging. Okay, imaging is everywhere. Okay, so what is imaging? Okay, so one thing I can give you a idea is, if you know whether there's a crack in the wall, and some people you can buy an ultrasound equipment from Home Depot and do that. But some people, if you're experienced, you just knock on the wall and see how does it sound. Itself is imaging. You want to see what's going on, what's in there. Okay, so in general, imaging is this physical process of visualize. If it's a simple process like your eyes, cameras, you really see it. But many times, it's not as simple if you cannot see through the wall. Or more complicatedly or more mathematically, you want from this response to infer, then you have to do more complicated process, the location, the shape, the material property of an object. And of course, depends on how you probe the things. For example, as I said, using light, the eye and camera, it's just the reflect light from the object. You see it, you visualize it. That's very simple because the light can penetrate the atmosphere to some distance. It's not so difficult. But then you want to see something in your body. The light doesn't go through. Then you can using ultrasound. You send some sound. That's very similar to what you do by knocking on the door, but the doctor doesn't knocking on your body. They use some special equipment to send in sound waves, and from the response, from the echo, they know what's going on. The sonar system, the same when you do underwater acoustics. CT radar system using electromagnetic waves. You don't see it, but they do send out this wave. And they're reflected by metals, some things. Then you don't see the visible. You don't use the visible lights, but you can use this to see through bodies. But what is optical imaging? Optical imaging is basically, it's very simple. It's just using visible or near infrared. Okay, for example, you're shining laser into your finger. Your eyes cannot see anything inside, but actually if you do some complicated measurement of how the light go through your finger and reflect it, by doing more complicated measurement, a complicated procedure, you can know a lot about information about the biological tissue. As I said, there are many ways of probing. There are reasons. One reason is why you use the sound to your body, not simple light, because one thing you can see is the acoustic wave can propagate deeper into your body rather than light. If you want to see under the earth, you use sound rather than use light, electromagnetic wave. That's for one reason. The other reason is why we do optical imaging, because when you probe, when you want to see things, different property react differently to different probing. For example, the optical imaging, one thing of course is non-invasive, right? You just shine a light on here. And also, it's not like X-ray, which is high energy, high intensity. In that sense, you don't want to take too many X-rays, too often, because it hurts your human tissue too. So this is very harmless and no invasive. The other thing is the optical property of the tissue can tell a lot of these functionality of the tissue. For example, the blood volume, if you have a healthy or non-healthy one, whether you have some blood clot in your brain, you just don't want to see the vessel, but you want to see whether inside there's a lot of blood or there's fewer blood, and so on and so forth. So this provides functional, when you do early cancer detection, you really care about the functional information rather than anatomical information, which X-ray can provide better information in that sense. And also nowadays, people, when doing molecular imaging, they design a lot of different, very delicate markers, biomarkers, dyes, so they can inject into your body, or I mean, right now the test is mostly on animals in the mouse. So these markers can go to the right place you want, maybe to where the cancer tissue and so on and so forth, tumor tissue. Then by finding where these markers are, they can monitor how the tumor is growing and the activity and so on and so forth. So there's a lot of these emerging and fast-growing quantitative molecule imaging now developing. And all that, the one important thing is the information sent out or you use probing in this range, visible light or infrared light. So then, of course, you need to know how you're using this light information, either coming from these biomarkers, you want to know where they are, or you want just shining a laser into, your body, this is too big volume. Usually, a good thing is for skin cancer, very near your skin, or like small joints, so on and so forth. That's more reasonable for this type of thing, because the light won't penetrate that far.